Okay, so we have a drag race between Alice and Bob. Everything in physics is represented as a dot. So we will represent Alice as a dot, and then Bob. Alice has fast reaction and she starts first, while Bob starts a little bit slower. However, what we want to find out is what time Bob passes Alice. How fast Alice is moving at this point. Here, to do that, you can use an equation, which is velocity equals acceleration times time plus velocity initial. Well, at this point, velocity initial equals 0, so this term falls out. Have our acceleration. So velocity 25 seconds is going to be 20 meters per second times 25 seconds. Which turns out to be 10 meters per second. So, at this point, Alice is traveling 10 meters per second. Next, we have to figure out how far she has traveled. So what is the distance between these 2 points? Well, since we have our velocities, I will use this formula. X equals 1/2 velocity plus velocity initial multiplied by time plus position initial. Well, this point is 0, so it falls out automatically. Our velocity initial here is also 0, so this falls out. So we are left with our velocity final and time. Alright. So x at 0.5 seconds is going to be 1/2 times our velocity times 0.5 seconds, which turns out to be 5, and then 5 divided by 2 equals 2.5 seconds. can cross out seconds, and we're left in meters. So at this point, Alice covers 2.5 meters before Bob even takes off. So since acceleration is a function of time, what would it look like on a graph? If the y-axis was position and x-axis would be time. Say Alice is in red. Alice starts at 2.5 meters, and her speed increases at 20 meters per second. Bob starts 0 meters per second. However, he's traveling a little bit faster at 24 meters per second. So at what time do they meet, or at what time does Bob pass Alice? This is the representation of such graphs. Alrighty. So we can figure out this problem by solving a quadratic equation. First, our equation looks like this. X equals 1/2 acceleration times squared plus velocity initial times plus x initial. So we will do one for Alice and another one for Bob. The beauty of quadratic equation that you can set each other equal to one another. So here, in Alice's case, our quadratic equation is going to look like this. 1/2 of acceleration, which is 20 meters per second, times time, squared, plus velocity initial. Now our velocity initial is here. Meters per second times time plus x initial, and our x initial is right here. That's going to be 2.5 meters. And as you know, this is going to be equal to x. Now in Bob's case, we will have 24 meters per second plus 0, because at this point he's not moving at all. His velocity is 0. Jeez. So this term falls out. Plus, he is starting at completely 0 here as well. So, 0, which falls out as well. And that is also equal to x. So let's just set Bob and Alice equal to each other at this point, which they should be. At that time, we should be equal at equal distance x. That's what we're doing here. So set them equal to each other. Alrighty. For this 1/2, right, we'll reduce instantly, which is going to give us 12, 10. We will subtract 12 from both sides. Which is going to give us the quadratic equation of -2 t squared plus 10 t plus 2.5. So that's 20.95 divided by 4. Well, 20 divided by 4 is 5.24 seconds. So now we know that this point in time is 5.24 seconds. Put our work to the side. Now, since we know the time, we can fill in the rest of the problem. For example, what is the time? So this question is answered. That is 5.24 seconds. But we can solve for speed. So what's Alice's speed? Well, honestly, it's plug and chug at this point. So we have velocity equals acceleration times time plus velocity initial. Well, for Alice, this is going to be acceleration 20 meters per second. Always keep track of your units as well. Squared times 5.24 seconds plus velocity initial. Well, since we are considering everything from this time, it is 10 meters per second. So all units cross out, and we're in meters per second, which is great. And if we do our math, this is going to be 115 meters per second. What about Bob? What is Bob's speed? Or velocity? So, plug in same equation. However, this time Bob's velocity is going at 24 meters per second squared. For 5.24 seconds. He's starting at 0. So we simply do our math and we get that he's going at 126 meters per second. We can get even more information than that. Alright. Next, what about, so we know the speed that each one of them is going. Alice is at this point moving at 115 meters per second. Bob is moving at 126 meters per second. What about, what's x at that point? At what x did they both meet at this point? Well, let's see. To solve for x, we can just simply use these equations right here. So, let's plug it in. X 1/2 of acceleration. So for Alice, this would be 20 meters per second squared times how long it took, which is going to be 5.24 seconds, because we know that at this point it is 5.24 seconds, plus velocity initial, that's that, so that's 10 meters per second, times 5.24 seconds, and plus x initial, which is 2.5 meters. 2.5 meters. Alrighty. And if we do our math here, we will get 329 meters. As you can see, this is going to be seconds squared, and these seconds going to cancel out. These seconds cancel out, and we're left in just meters with addition. It's good. Units are good. If you would like to double check yourself, this was for Alice. If you would like to double check yourself, you can do Bob as well. It's actually even simpler, because he's starting at 0 with 0 velocity. So all you have to do is plug in 1/2 of his acceleration times the time it took plus 0, that's the velocity initial, plus 0 x initial. So these two fall out, and we're left with which produces the same answer. So x at that point is 329 meters. And that is as much as we can solve the drag race problem. There's really nothing else we could possibly want to know about such a problem. This is constant acceleration.